Now. Okay, so you were supposed to do the evens by yourself, which I think we did two together, and you were supposed to do the rest by yourself. Which ones would you like me to go over? Okay, 14 is what I heard first. Okay, number 14. Number 14 is a little different because you have three different things to multiply. Well, I would first start by multiplying these first two. What is 8i times I? 8i squared, which then will become negative 8. And the reason it becomes a negative 8 is because I squared equals negative 1. So 8 times a negative 1 is negative 8. Now, so I'm done with the 8i times I. It became negative 8. But now I have to bring down that 5 plus 10i. And now what do I need to do? Distribute the negative 8 to both of those. What is negative 8 times 5? Negative 40. And what's negative 8 times 10i? Negative 80i. Okay, is there anything we can combine or simplify? No, those can't be combined. This is just an I, so it's not like it's, if it were I squared, we could continue, but it's just an I. So that's your final answer. Okay, any other questions? Nobody else have any? Number 12? Okay, I'll do 10 first, and then we'll go to 12, okay? All right, number 10, negative 10i cubed. Well, doesn't negative 10i cubed mean that you're multiplying negative 10i 3 times? Okay, first deal with the numbers. What's negative 10 times negative 10 times negative 10?
Negative 30i.
Negative 1,000.
Whoa, never mind. I am like...
You were adding. You were adding. We're multiplying.
No, it
Okay. Well, let's just say you were. Okay, now look. You have an I times an I, which is I squared. What does I squared equal? So if you put that negative 1 next to the negative 1,000, what happens? It turns into positive 1,000, but then don't we have that third I left over? So the answer is positive 1,000i. Okay, now let's look at number 12. 5 plus I squared. Well, 5 plus I squared means that you're taking 5 plus I and multiplying it by itself. So once you've written it out, you can see that you're going to need to FOIL. 5 times 5 is 25. 5 times I is 5i. I times 5 is another 5i. And I times I is I squared. Okay, now what can we do? Combine like terms. So we have 10i. And then I'm going to cross those out because I'm not going to need them anymore. What else can be simplified? I squared equals negative 1. So we end up with a 25 minus 1, which is 24. And remember, with complex numbers, the standard form is A plus BI. You always put the real number and then the complex number. Okay, any other questions from the evens? Okay, remember, these pages 16 through the end of this packet, will be used for next Friday's 10 squared.
Wait, so
yes.
Ms. Dale, number 16 will
yes, to negative 15i squared, which will turn into a positive 15. And then you would just distribute the positive 15 to the rest of it, and that would give you negative 15 plus 30i. Okay, any other questions? 20? Okay. All right, number 20. Shh, pay attention. The first thing I would do is multiply these first two. 5i times 8i is 40i squared. Well, what will 40i squared become? A negative 40. And then you have to bring down the remaining part and distribute to it. Negative 40 times negative 8 is positive 320, and negative 40 times 7i is negative 280i.
Isn't this something you said sometimes the parentheses really don't matter?
That was more on the other page when they had like 2 plus 2i. Like that was that. Okay, any other questions? 16?
We already did 16.
No, we didn't. Okay, why don't y'all take a second before I just do it and you try it yourself really quick. Okay, shh, pay attention. Shh, Monet, you ready? So, we've learned how to add complex numbers, subtract complex numbers, multiply. So, obviously now we're going to divide complex numbers. Now, the first thing you need to learn how to do is the complex conjugate. Some of you will remember this from last year. If you're dealing with a complex number, a plus bi, the conjugate would be a minus bi. But keep in mind, you only change the sign only on the imaginary part. See how the a was positive and it's still positive? Only the bi changed from positive to negative? So let's try some examples. 2 plus 2i. What would the complex conjugate be? Right, 2 minus 2i. What about for the next one? What would its complex conjugate be? Right. Okay, now, before we just go on, to make sure everybody completely understands that, go to the next page. And I'm going to give you like 2 minutes to work that whole page. Okay, you have 2 minutes to work 1 through 10. Okay, so to divide complex numbers, you cannot leave an imaginary number in the denominator, so you have to multiply by the complex conjugate, which is 1 minus I, and you have to do that top and bottom. So now that you see that, what are you going to have to do when you have something like that and you're multiplying? FOIL. When you're doing this times this, you're going to have to FOIL, right? You would have only cross multiplied had the equal sign been in between those. Okay, so when I FOIL this, I'll do the 3 times 1, which is 3. 3 times negative I is, right? 2i times 1 is positive 2i. And then 2i times negative I is negative 2i squared. Okay, now what do we got to do to the denominator? The same thing. So first we do the first terms, which are 1 times 1. Then we do the outer terms, 1 times negative I, negative I. Then we do the inner terms, I times 1, positive I. And then we do the last, I times negative I, negative I squared. Okay, so does everybody understand what we've done so far? The whole goal here is to get the imaginary number out of the denominator, so you multiply both the top and bottom by the complex conjugate of that denominator. And when we did that, we saw that we had to FOIL. Now let's just start simplifying. Focus on the numerator. What can be done to simplify the numerator? Negative 3i plus 2i is negative I. And you can write a 1, but you don't have to. Okay, so now I'm going to cross that out. That way I know I've used it and it became that negative I. What else can be done in the numerator? Right, this negative 2i squared becomes a positive 2 because if I squared is negative 1 and you multiply that by negative 2, you get a positive 2. And so now we have 3 plus 2, which is 5. Okay, now let's do the same thing to the denominator. What can we do to it? Right, negative I plus I cancels each other out. What else happens? It turns into a positive 1. Because look, the I squared is a negative 1. So you end up with a minus a negative 1, which is a positive 1. Does that make sense? And then 1 plus 1 is 2. Now, remember how we've talked about standard form is a plus bi? You have the real part and the complex part. So we have to split them apart and put the 5 over the 2, and then the minus I over 2. You have your real part and your complex number part. Yep. Okay, now let's look at number 1. Okay, you can never leave an imaginary number in the denominator. So to get it out, you multiply by the complex conjugate. What is the complex conjugate of 3 minus I? Right, and you do that on top and bottom. Does anybody know why you're doing it to the top and the bottom? Okay, what is 3 plus I over 3 plus I? 1. So when you multiply by 1, are you really changing the problem? No. So that's why you're allowed to do that, because you're really not doing anything but multiplying by 1, and we all know multiplying by 1 does not change the actual problem. We're just having to do this to get the I out of the bottom. Okay, so now what do you see that we're going to have to do to the numerator? FOIL. So 6 times 3 is 18. 6 times I is positive 6I. Negative 3I times 3 is negative 9I. And negative 3I times I is negative 3I squared. You all see how important it is now to know how to FOIL? Okay, now what do we do to the bottom? FOIL again. So we have 3 times 3 is 9. 3 times I is positive 3I. Negative I times 3 is a negative 3I. And negative I times I is a negative I squared. Okay, now that we've FOILed the numerator and the denominator, we can simplify each one. How can we simplify the numerator? Right, 6I minus 9I is negative 3I. And see how I went ahead and wrote it to the right side because I know that standard form, it comes second. Now what else can be done in the numerator? Okay, what does it become? A positive 3. So now I have 18 plus 3, which is 21. So I'm done simplifying the numerator. What can I do to the denominator? Right, and isn't that our goal, to get rid of the i's in the bottom? Okay, so now we're left with a 9 minus I squared. Well, what is I squared? A negative 1. So basically we're left with a 9 minus a negative 1, which is like a 9 plus 1, which is 10. You got to break it apart because you have to have your real part, which is 21 over 10, minus your complex number, which is 3 over 10i. That would be the answer for the 10 squared. I normally try to circle or box in the final answer, and y'all need to do that as well on your paper. Okay, so now before I work out number 2 for you, let me give you a minute head start to try to see what you can do with it before I just work it out. So try number 2. Okay, you cannot have an imaginary number in your denominator. So you have to get it out by multiplying by the complex conjugate, which is 2 minus 2i over 2 minus 2i. And the reason that's okay is because really we're just multiplying by 1, because anything over itself is 1. So when you multiply 1, you're not actually changing the problem. Now, what do we have to do to the top? We have to FOIL that times that. All we got to do is distribute, right? 6 times 2 is 12. 6 times negative 2i is negative 12i. Okay, now over. On the bottom, you do have to FOIL. 2 times 2 is 4. 2 times negative 2i is negative 4i. 2i times 2 is positive 4i. And then 2i times negative 2i is negative 4i squared. Okay, can anything be done to the top? The top, no. Okay, but the bottom, the outer and the inner terms cancel each other out, and they will always cancel each other out. So when you're doing these problems, couldn't you just kind of skip straight from the F to the L and skip the outer and the inner because they're going to cancel? If you're not able to handle that though, just FOIL, okay? Or double distribute, whatever you want to call it, until you get good at it and you just see what happens. Okay, now what does negative 4i squared become? A positive 4, and so we have a 4 plus 4, which is 8. So now we have a 12 over 8 minus a 12 over 8i, which is correct, but you would not see that as one of your 4 choices. Why do you think that? You could reduce. What is 12 over 8 reduced to? 3 over 2, and then minus, that's also 12 over 8, so 3 over 2i. So that would be the final answer that you would see as one of the answer choices. Okay, now turn to the next page.
Oh my goodness.
Okay, actually the next, because we just did that page. Alright, these are just dividing complex numbers. I just made it multiple choice so that after you do all that work, you'll at least know if you've done it right. Plus, when you take the test, you'll have 4 choices to look at. So let's look at number 1. Let me zoom in on it. Okay, we cannot have this I in the denominator, so how do we get it out? We multiply by the complex conjugate on top and bottom, and what is that complex conjugate? Right. Okay, what do we need to do to the top? Distribute. 8i times negative 8 is negative 64i. 8i times negative 3i is negative 24i squared. Okay, what do I have to do to the bottom? FOIL. But like we just discussed, the outer and the inner are always going to cancel each other out. So couldn't you basically just do the F and the L of FOIL? What are the 2 terms that are first? Negative 8 times negative 8 is 64. Now I'm not going to write them down, I'm just going to show you. If you did the outer, negative 8 times negative 3i is positive 24i. Then if you turn around and do the inner, you get a negative 24i. Those just cancel each other out. So you can skip outer and inner. What are your last terms? 3i and negative 3i, which multiplies to a, right? Okay, now what could be done in the numerator? Right, that negative 24i squared will become a positive 24. So now how do I write the numerator? Right, you always put the real number first. Okay, what can be done in the denominator? That minus 9i squared becomes a plus 9. So what's 64 plus 9? 73. And before you really even split it apart, you can see the right answer since you have choices. What's the right answer? A. Okay, number 2. What do I need to do first? Complex conjugate, which is, right? Okay, starting with the numerator, what do I need to do? Right, I'm just going to distribute, and that gives me a 4i, and then 2i times 8i is, right, over, what do I have to do with the bottom? FOIL, but we always know that the outer and the inner are going to cancel each other out. And so what are your first terms? Which is 4, and what are your last terms? Which is negative 64I squared. Okay, now what can be done to the numerator? That all becomes a negative 16 or minus 16. So how do I write that over here? Right? And then what happens in the denominator? Right? That becomes a positive 64, and so combine it with the 4 and you get a 68. Now you break it apart, so you have a real part and a complex part. But do you see that as an answer choice? Why not? You can reduce it. What is negative 16 over 48? I mean 68, my bad. What's negative 16 over 68? 4 over 17. What's 4 over 68? 1 over 17. And since you don't have to write the 1, they just have the I. So big. Okay. We still have 9 minutes left in class, so you need to start working on the rest of this page. And then once I call switch, if you're not done with page 23, you finish it for homework. Page 24 is for tomorrow.
Well, I'm the overachiever, dude.